All right, this problem here, these three problems, are just using the formula to solve for delta S, change in entropy, change in randomness, and those numbers come right from your reference guide. And this is done using the same formula as we did for delta H, other than the only difference is which column you're looking under. That little knot, again, means that it's done under standard conditions. So we've kind of, like chemists and scientists, have set down the framework or the guidelines that anytime they report their data, it should be under similar conditions. So it's easy to report worldwide, and those conditions are 25 degrees Celsius and 1 atmosphere of pressure. So our delta S is equal to the sum of the S naughts of our products minus the sum of our S naughts of our reactants. All right, I'll do just one of them because the rest are done the same exact way, but I'll put the answers for B and C on here. Here, this is my product, and if I look up in that table of delta S's, I find that my delta S naught is equal to 126.8 joules, and our units are joules Kelvin. I think some will say joules per mole Kelvin. That's just saying we're dealing with a mole of each of these substances. And that's our only product, so now we're going to look at the sum of our reactants, and I look up carbon monoxide, I end up with 197.7 joules per mole Kelvin, and then sorry, it should be a plus sign there, 2 times the one for hydrogen, which was 130.7 joules per mole Kelvin. And if I do this, plug this all into my calculator, let me step back. My delta S naught. If I add all these up and find the difference between the reactants and the products, I should end up with a delta S of negative 332.3 joules per mole Kelvin. And this is actually showing us, remember delta S is randomness. We have we're actually getting a decrease in randomness. And that makes sense if we look at this. We've got 3 moles of a gas, very random, combining to form just 1 mole of a liquid. So we're going to have a negative delta S. Our randomness is decreasing. If we look at letter B, done the same way, and we should find out a delta S as being 24.9 joules per mole Kelvin, or joules per Kelvin, either way. And our delta S naught for letter C will be negative 216.35 joules per mole Kelvin. All right, very similar. I'm not going to expand too much on these. Very similar equation for delta H. We're just choosing different numbers from different columns. The biggest difference is for elements in their standard state, our S value, our entropies, are not 0, like our enthalpies were 0 for that. So you'll have to look up numbers for those. And obviously different units. All right, that's how you do these.